taken the time to type in all of these data values into our two lists, and we decided we were going to do the second score minus the first score for our list 3. So if you had a chance to do that, remember you can go over to, so here we are, list 1, there we go. So if we go over to list 3, remember if you go up here, all right, so make sure list 3 is highlighted, right? And you can type in L2 minus L1, hit enter, and it will populate it for you. All right, if you haven't had a chance to do that, go and do that now. All right, I think I can do it again. Let me see if I clear it. All right, so do second list 2 minus second list 1. We'll do it for you. Okay, bless you. All right, so you type that in. It makes your life so much easier, right? The one we did last Friday about the, the resting pulse rates, right? That was a little bit easier to do mentally. This one, not that you couldn't do it mentally, but it would just take you a lot longer since there are 30 different students. All right, so we're doing a confidence interval. Who's got our first thing we need to do? And notice I do have lots of space. So we got a whole page, so plenty of space to do all this stuff. Independence. All right, what do you got? Talking about SAT scores, right? SAT prep class. I think he's answering you.
One person's score doesn't affect another.
I love it. Okay. What I'm actually going to do, Eduardo, is take that and kind of focus it on what it's asking about. What are we focused on when we look at these two scores between a student? The improvement. So I'm going to say one student's improvement in their score will not affect another. But I don't think the AP exam is going to care that much if you just said scores. But I just want to make sure they know we're talking about the improvement. So one student's improvements in scores. What's wrong, Australia? Okay. I'll check the recording later. No. Okay, now, I'm totally fine with doing that. I would have done what assumption first? Remember what one I would have done first? It doesn't matter the order. The paired data assumption. I just want to get it out of the way that we know that these two groups of data, the first scores and the second scores, are linked, and that link is they are the same students 1 through 30. So I'm going to say that the first scores and the second scores are linked. They are the same student. Yes, Thomas.
We're doing a Kahoot on Wednesday, right?
Yes, for a grade.
Is the Kahoot going to be identification of what kind of test?
Yes.
Okay.
It'll be like a scenario, and you've got to choose what you would do. You don't have to do it. Like, you're not going to then do it. You just have to decide which one would you do. Because remember, on the test next week, I'm not going to tell you, like, all right, guys, the first free response is this kind of test.
Is it going to be like a 1T test, like 1 14T test, or 1 T test?
No proportions. No proportions.
Okay.
So 1 sample t-test, 2 sample t-test, or a paired t-test.
Those are the only options.
Those are the 3 options. Now, I might throw some intervals in there. Okay. Does it say anything about random? Random?
No. Wait,
Random?
yes.
It does. Nice. So these students were randomly selected. So that's nice. And then let's do our sample size of 30 times 10, which is 300. And so what do we hope is true about this SAT prep course? That there are more than 300 students participating in. So there are more than 300 students in this SAT prep course. Would you guys consider your junior year college readiness to be an SAT prep course?
Yes.
Yeah.
Post. You should count these.
Okay. Now, what do I do next, right? Remember, this is means, not proportions. This is means. So what are we doing next? We're doing the normal population assumption. So do I have the first score and the second score for all the students participating in this prep course? I do not. But if I did, and I found the difference, and then made a histogram of those differences, what should it look like? Normal, unimodal, and symmetric. So I'm going to say the population histogram for all student score differences would be normal. And if you ever wonder, maybe you've seen it if you helped out at open house, or maybe you've seen it if you saw it at the gala. I'm not sure if they were blasting this everywhere, but we get with a lot of the communications that I receive about Cristo Rey Jesuit is the improvement in the average SAT score over the last few years, right? And how are they getting that? This right here, right? Are they doing a sample? Probably not, right? Our school is small enough, they're probably just doing a census. Everybody. Right? So your data is in there. Yes. Yay. Hopefully that's good. Okay, so can we check a histogram? That's, well, until next year, right? That's the hope. Each year we hope to beat it. So do we have the data? Yes, we do, right? Remember list 3? So let's go ahead and make a histogram about these differences in list 3. Remember, I did the second score minus the first. So I'm hoping to see positive numbers, right? An improvement. If I see a negative, that means the student did worse the second time around, right? That's not a good look for the prep course. So turn the stat plot on, and we've got list 3. So second, number 3. Hit graph, zoom 9. All right, what do we think? No, you had it a while ago, all right? Yeah, it definitely looks unimodal. I mean, remember, guys, roughly symmetric here, right? Roughly. Yeah, I mean, like,
Good enough.
maybe if you needed to say there was some skewness, maybe, right? But overall, am I going to, like, search for skewness? No, not in this problem. So I'm going to sketch this, and we've got enough room, so you don't need to do it to the side. You can do it straight underneath, or if you want to do it to the side, you can. So this is for our, let's see, difference in scores. Now, it looks like we do have, I'd have to look at my actual data, but it looks like we do have at least a couple of students that did worse, that performed worse, based on the fact, you guys see how this first bin is moving to the left of the origin? So we do have some students that actually did worse on their second one, which is not good. That's not what we're hoping for. Something like that. All right, I'm going to say that this histogram is unimodal and roughly symmetric. Remember, if you make a histogram on the AP exam and it doesn't look unimodal and roughly symmetric, are you going to stop doing the work? No. Make a little note that you're maybe concerned about the fact that it's not, but don't just stop. Okay, keep going. Thomas, I know you always like when I do my recordings on the free response questions for the review. So this morning I made one, all right, where one of the histograms was definitely unimodal. I think it was actually perfectly symmetric. And one of them was not. So I made a note of it. I kept going, all right? I also am doing that because on Monday, so next week is Monday the 6th, and I'm going to miss your class because I have a dentist appointment, all right? Don't worry. We'll make sure on Friday you ask as many questions as you can. But if you're still worried, I'll make sure that my videos are all uploaded for the free response questions. So at least you can watch my multiple choice video again if you want, and the free response ones. Okay? All right. You guys ready for the statement? All right. So the conditions have been satisfied. So I will use the T model with who's got the degrees of freedom? Nice, right? Remember when we do the paired T interval or paired T test, we go back to what we did with a one sample, right? So it's just the sample size minus one. So 30 students minus one, so 29 degrees of freedom to run a paired T interval. Now, I have run out of room on the first page. If you haven't and want to keep going, that's fine. I'm going to flip to the next side where I have a whole mess of space to do the actual math. All right, so if you feel ready to flip, feel free to, or you can keep going there. All right, so I'm going to write down my stuff they gave me. The sample size is 30 students. Degrees of freedom, 29. Do I know my D bar yet? My average difference? I don't. Do I know my standard deviation of the differences? No, so I'm gonna leave those blank, okay? Anybody got the formula for the interval? D bar plus or minus T star. If you say T score, that's okay, but we want to make sure we know that it's T star with 29 degrees of freedom times standard error of D bar. All right? And hopefully you know that formula, which is the sample standard deviation over the square root of the sample size. All right, let's go ahead and take the time, since we have the time and the space, to find that T star. All right, do you guys remember how to find the T star? No? No one does? Sad. It is second vars, but not normal, right? Because we're not doing the normal model. It's not inverse norm, it's inverse T. What's up? Which one? So it's squared in the standard error for the difference of two sample means.
We have them linked.
Correct. Because we're linked, we're kind of going back to chapter 23, where if there's only one, then we don't have to square that. Yeah. Remember, they're squared because we add the variances. Okay, so what's the level of confidence? 90. So how much is in each tail? 5%. Remember, this is a skill that you will need to know for the AP exam. All right, I hope in May you see that problem, you do it, and you go, yes, I got one right. I can't wait to see how awesome you did in July. All right. What? Maria?
I won't be there to see the look of whatever.
The look of joy when the screen loads. Oh my God.
Oh, yeah.
What? Okay. Oh my God. Somebody get me started. Dad, can I? No. Okay. So we're doing a T interval, which is, oh wait, I'm sorry. We wanted to get the T star. Might be second vars. number 4. Oh man, mine's got that. Hold on. Let's see if I can get it. That's not what I wanted. There we go. So 0.05. And then 29. Yep. So T star is 1.699. 1.699. What's up, Eduardo? Gave you an error. Okay, let's find our stuff. You can always reset it, but then all your data goes away, so sad. All right, I got list 3. I got 0.9. Make sure you change yours to 0.9. I already ran it this morning.
Is it number 8?
I believe so, yeah. Because isn't 7 the Z interval? Yeah, we want the T interval for one group of data.
Are we ever going to do the Z stuff?
Yeah, we did the Z stuff.
Okay.
Were you not here?
I've
That was proportions. Don't worry, it's all going to come back around after
Sure.
April 1st.
Sure.
We got a month to review. We got a lot of reviewing to do, right? Okay, let's see what we got. I'm going to write down my statistics first, which was 63.2 is the average difference, and the standard deviation is 41.9 points. I'm going to plug in my stuff here. Oops. All right, so what is my interval? The low number is 50.2, and the high number is 76.2. All right. We're ready to write our statement to finish. I am 90% confident that the average improvement on test scores is between 50.2 and 76.2. That's good for this company. Why is it good for this company?
Because they are improving the scores.
Right? It looks like they're on average, their lowest one is 50. So at least you can say like, oh, we expect you to do at least 50 points better, maybe all the way up to about 75 points. And what do I not have in this interval? 0, right? If I had 0 in the interval, I would be concerned. No one would send their students to this prep course if 0 is a possibility, right? I know it's a possibility, but if it's in your interval, then I'm worried that there actually is no difference in how they're performing. So like, what are you guys doing in your prep course?